Hello everyone, we're going to discuss one final Modbus type today. I know that I've told you about serial Modbus and its 127-byte input and output buffers. And we've talked about TCP Modbus with its 1023 input buffers and output buffers. But there's actually one third type that we haven't gone into, and that is plug-in Modbus. Plug-in Modbus is serial. And it's probably the preferred method of doing serial when you don't have a Mod I/O card, or if you want to use a Mod I/O card with brains rather than the internal Mach3 processing of a Mod I/O. I have my Mod I/O connected to my plug-in Modbus at the moment, so I'd like to show you under functional configuration. If we say set up serial Modbus control, you can see we come up with a completely different dialog than we do under the non-plug-in related setup. In this setup, we have similar settings to normal serial Modbus, and we have the exact same test Modbus. But there's a difference. We have a checkbox for Modbus run on and off. We can turn off Modbus or turn it on with that simple checkbox. And here we have on the far left-hand side, we have configuration numbers, and you can have up to 63 of these configurations. Each configuration can hold up to 127 transfer registers. So let's take a look at a quick example. As you can see, if you can read this, and you probably can't, so I'll read it off to you. I have configuration 0 enabled. I've given it a name of Mod I/O. These names are usually read by a plugin, and they're really just there as a notification of what you're using it for. I only have two configurations turned on. They're both set to port 1. So that's serial port 1. Slave number 6, which my Mod I/O happens to be set to as a slave number. Yours will probably be a 1 or whatever your slave number is for your Modbus. And we can also tell it how often to refresh the data. So on 25 milliseconds, this tells the serial system to refresh this configuration 0 every 25 milliseconds. We are telling it the Modbus variables are located at 1150, and we want 7 of them. So the first 7 16-bit words of the Modbus will be transferred in from address 1150 to addresses 0 through 6 on the plug-in Modbus, which is what I've named it, plug-in Modbus registers in configuration 0. This will all make better sense in a moment. The final column here is direction. We tell it whether it's an input or an output. Input means we're reading from the PLC or the Mod I/O or whatever we're connected to. This is a very good screen for normal general PLCs. And configuration 1, which is the second one, you can see I call it Mod I/O channel 2. This is an output where I've given it a higher refresh number, meaning I only want it to refresh this one every 50 milliseconds because my outputs to the Mod I/O I consider to be less important. You can juggle these refresh numbers around, and you can set as many configurations as you wish on a PLC so that certain words are pulled in faster than others, and certain words are pulled out faster or slower than others. And you can see, if you could read this anyway, you can see that what I've told it to do is starting at address 1040 in the Modbus, fill it with 2 registers. So it's going to take the first 2 registers from configuration 1 and send them into the Modbus starting at address 1140. Those of you who are familiar with a Mod I/O card will know that the registers that you get from a Mod I/O and send into Mach3 begin at address 1150. The addresses that you send out to in a Mod I/O start at address 1040. So here we have, basically I'm doing 2 operations. Every 25 milliseconds, I'm sending 7 registers from the PLC, or Mod I/O in this case, into configuration 0. And every 50 milliseconds, I'm sending 2 registers from configuration 1 to the Mod I/O on address 1040. So using this screen, you can set up to 64 different configurations of Modbus data. And each configuration has 127 bytes of data, or words of data maximum that you can use. My mod IO is currently running at the moment and is every 25 milliseconds transferring in the first 7 registers of the mod IO, and every 50 milliseconds it is sending 2 registers out to the mod IO. And these are going into configuration 0 and 1. 0 is receiving data. Configuration 1 right now is set up to send data. As I said, you can set up to 64 of these 63 of these configurations, and thus you can send whatever memory words you want at whatever timing intervals you want back and forth from any PLC. This is serial only, take note. This is not TCP. Because TCP is so fast compared to serial PLCs, you may want to be able to juggle your addresses this way to set up various configurations that run at various speeds, more or less setting a priority for your data. Now, I have a brain running at the moment with this particular configuration being used. I'll show you how we wrote it. Here is our brain editor, and you can see if I go to add an input and I select Modbus, there are 3 types of Modbus listed now. There is TCP Modbus, which we've already talked about. There is serial non-plug-in enabled Modbus, which is the normal serial Modbus that you've been familiar with from the start. It is the Modbus that Mod IO typically uses. And then we have serial plug-in Modbus. If in Mach3 you've selected plug-in enabled serial, this is the one that you want to use. And you can see that when you select serial plug-in enabled, not only do we set a Modbus address up here, and that number would be 0 to 127 for the data within that configuration group, but you set a configuration number. So by telling it that I want, say, address 2 from serial plug-in enabled configuration 0, we would get Modbus address 2 plug-in enabled, and it is currently in configuration 0, and that's what this mod 2 P0 means. Modbus address 2 plug-in enabled configuration 0. The same thing happens when we terminate. We can let's just add a NOP lobe to this, and then we will click on that NOP and terminate it. You can see that we can terminate to the same areas in Modbus, so we can send things from an input section of the Modbus, run it through a formula and send it back out to the Modbus. Or we could select Mach control variables, and in this case we could select the MPG1 count, for example. And this tells us then to take address number 2 on configuration 0 of the plug-in serial, do no operation to it, and send it to MPG1 count inside Mach3. That's the general creation of Modbus type of data in a brain. Let's take a look at what the effect of that is. I'm not going to save that because I already have one made. So we'll go to brain control. You can see I have a Mod IO MPG1 brain here that is enabled and running. I'm going to hit View Brain so that you can see it run. Interesting here is we can see that I'm using Modbus address number 6, plug-in enabled, configuration 0, and we see a flashing number. This is the timer tick variable coming back from a Mod IO. The Mod IO is kind enough to send a message saying how long each message is taking. And it tends to be in 2 millisecond increments. So I've set a formula which says input A multiplied by 0.002. The answer is shown now when you're viewing a brain. You can see that the answer is floating some because the input timing is floating a bit. And that's being sent out to the MPG tick count. So the MPG tick count is informing Mach3 exactly how long it's taken you to give each message as you rotate an MPG or each message of the Modbus coming through. It is not necessary to set a tick count. Tick counts tend to make the MPGs on a PLC a little bit smoother, but if you do not put this line in, it wouldn't make any difference at all. Your MPG would still work. So the key of this brain is the second line, which is Modbus address 0, plug-in enabled, configuration 0, and then it tells us now what is in that register at the moment. And if I rotate my MPG here, you can see the number changing. The mod IO is sending me a new clock count, or a new count of the MPG as I rotate it. You can see I'm feeding it into a NOP, a no operation lobe. The no operation lobe is simply passing the number 20518, which is what it's getting from the TCP. And we're terminating that out to MPG1 count in Mach3, which is getting the same number sent through to it. So if I close this brain viewer and close this and reset Mach3, and I rotate the MPG, you can see that the MPG is now operating Mach3. Now that's an MPG coming in from a mod IO. It is not being processed by Mach3 at all. It is simply a brain taking the data from that MPG register and feeding it into Mach3's MPG1 counter. And this means that you can feed an MPG in now from any PLC, whether it's a DL5 or a DL6 or basically any PLC with a Modbus attached. All you need to do is create a brain which selects the appropriate Modbus location and sends it into Mach3's MPG counter. From that point forward, you should be able to calibrate your MPG and move it. And the good thing about it is when you're looking at it on the brain control editor or the viewer, you'll be able to see exactly what is coming in and what is going out. Another good feature of this is anytime that you create an input from a Modbus register, no matter what that Modbus register is, you can watch in real time what the numbers are in that Modbus register and see what they're doing. On a terminated output, you can also see the actual numbers being sent into Mach3, and you can see them change in real time. This should be a big improvement over what we've had, and gives you the ability to troubleshoot and debug a brain in real time to see exactly what's going on. This was just a quick demonstration, just a short video to show you what changes have been made. This version will likely be released within the next day or two. That's it. Thanks. Hello everyone, we're going to discuss one final Modbus type today. I know that I've told